Alright, the next section in Chapter 3 has to do with the mole concept. The mole, this is the official definition, the given quantity of a substance that has as many molecules or formula units or atoms as exactly 12 grams of carbon-12. Okay? But that's a very complicated thing. Basically, atoms are so small that we can't see them with the naked eye. We can't see them with any optical microscope. So it takes a large amount of atoms or molecules in order for us to be able to see them. So to me, the mole is very much like saying a dozen. Okay? A dozen always means what? It means 12. So it doesn't matter if I say I have a dozen cars. I have how many cars? I have 12 cars. Okay? If I have a dozen cans, okay, that's really similar, but oh well, it's 12 cans. Okay? A dozen people is 12 people. Okay? So it basically, a mole is a quantity that we talk about, but it's a really big number. Okay? And that number is down here at 6.02 times 10 to the 23rd. So basically, 1 mole is equal to 6.02. It doesn't matter what I'm counting. I can say that I have 1 mole of cars, which means that I have 6.02 times 10 to the 23 cars. Okay, so you use it in very similar manner as you do a dozen. Okay, the only difference is it's a really, really big number. Okay, so if I start down here, I've got 6, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. Okay, so if I go back, that's comma, 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 comma. So if this is thousands, this is millions, this is billions, this is trillions, and I don't really know what comes after trillions, but you can see it's much bigger than that. Okay, so basically, this is the number that we use. This is what's represented by 6.02 times 10 to the 23rd of something. Now, you will see it as atoms per mole, molecules per mole, ions per mole. Like I said, I can have cars per mole. So it's basically, it doesn't have a start. It's just 6.02 per mole. On the periodic table that I give you for the test, that's represented as saying mole to the minus 1. This means the same thing as that does. Okay? And the other term we're going to introduce is called molar mass. Okay? So in the last video, we had molecular weight and we had formula weight. Molar mass is just a more generic term so that we don't have to distinguish whether it's a molecule, an atom, a formula unit, whatever it is. Okay, so this is just the mass of 1 mole of substance. So this is the same thing as formula weight and molecular weight, but we're just going to use it as a more generic term. Okay, so the mass of 1 mole of molecule is equal to its molecular weight. Okay, and we're going to use this then to calculate the mass of 1 atom. The formula for this is that it's the molar mass divided by N sub A. N sub A is the Avogadro's number from the previous slide, so 6.02 times 10 to the 23rd. And that is given to you on the periodic table. This formula, however, is not given on the formula sheet. Okay? So this formula is not given to you on the formula sheet. You can determine what formulas are given and what formulas are not given by looking at the textbook. At the end of each textbook is key equations. If the equation is at the end of the textbook, then at the end of the chapter, then it is given. If it's not at the end of the chapter, it's not given. Okay? So we're going to use this then to calculate the mass of 1 atom. Okay? So it says calculate the mass in grams of each species. Alright, so we see, we're going to use this formula here, that molar mass divided by Avogadro's number. So the molar mass of bromine is right here is 79.90. So the mass is the 79.90 divided by 6.02 times 10 to the 23rd. Now, pay attention to this. Anytime you see, change colors here. Anytime you see this times 10 to the 23rd here, on your calculator, you do not want to enter that, because what you would have done then is you would have entered 79.9 divided by 6.02 times 10 to the 23rd. So anytime you see this expression, you want to enter it as EE on your calculator, which is going to show up as 1E in the display line, 23. Or if you have a different calculator, it could be AEXP 23. And there's some calculators out there that you'll actually just have to put parentheses 6.02, and then you use the times key, 10 raised to the 23rd, but it can close parentheses. It has to be one of these three things, though, otherwise you're going to get the wrong answer here. Okay? And so the answer to this one is 1.33 times 10 to the minus 22, and the units are grams. So if you don't get minus 22, that means that you did not use one of these three things correctly. All right, moving on to PBr3. Okay, again, we have to do the molar mass. Okay, phosphorus, there's one of them, and it's 30.97. And I'm just getting these masses from the periodic table over here. I just happen to know a bunch of them. 30.97. Bromine, there are 3 of them, and each one is 79.90. And I thought I pre-did all these calculations, but I didn't. So 3 times 79.9 is 239.7. Oops, 239. So I have no memory. 0.7. And so I add those together, and I get 270.67. So then I take the 270.67 divided by the 6.02 times 10 to the 23rd, again using EE, EXP, or parentheses, and I get 4. When I round it to 3 significant figures, I get 4.50 times 10 to the minus 22 grams. Okay, so again, I want to be able to have a minus 22 here. Okay, now I don't have a whole lot of room for the end of the slide, so I'm going to go over here and work it up here. So again, for iron 3 hydroxide, this time it's an ionic compound. Naming wise, first you have to ask yourself, is it ionic, molecular, or an acid? This one is molecular, so this is phosphorus tri, because it's molecular, bromide. This is ionic. Iron is a transition element right here, so I have to put the charge. So I have to know that OH is a -1, so therefore it's iron 3. Hydroxide. So this is one of those from table 2.6 that you need to know. Okay? All right. All right, so the molar mass, way up here, the molar mass is for iron is 1 times 55.85. For oxygen, it's 3, because, yes, each hydroxide has 1, but with the 3 there, I have to use 3. 3 times 16 is 48. And hydrogen, there's also 3 of those, times 1.01 gives me 3.03. So I add those together, and I get 106.88, and that's in grams per mole. And so then the mass is the 106.88 grams per mole, divided by the 6.02 times 10 to the 23rd. And when I do that, I get 1.75 times 10 to the minus 22 grams. Okay? And so that's the mass of 1 formula unit of iron 3 hydroxide. And that is the end of this video.